Hello everyone, my name is Amol More and welcome to our channel Solution to Blackbook. Now today one of our student has asked us this very interesting question in which if A and B are non-negative numbers. Non-negative numbers means they will be positive and they won't be negative numbers. It means it could be also 0. Okay, so A and B, any one of them could be 0. That is what they are meaning to say. But at prima facie we can say that A cannot be 0 because A is over here in the denominator. Whatever, let us move. A plus B equal to 2, then we need to find out the minimum value of this very big expression. Now how to do such kind of questions? So the first thing that should come to your mind is AMGM. This is the first thing that should always come to your mind, and the last thing that should come to your mind is derivatives, application of derivatives, because that is a very long concept and it will take a lot of your time, and many a times you might end up getting the wrong answers because it becomes a very long and lengthy derivative. Okay, so definitely we won't be using this. Okay, but there is some trick in between here, to which I call the graph trick, the technique of graph. So for that you need to have a very vivid understanding of graph. If you don't know how to plot the graphs, you should go and visit my playlist Play with Graphs, which is provided in this particular channel, and you can get a very well idea of how to plot graphs. So before we start the solution, before watching any video, please make sure that you subscribe to our channel, and after watching a video, if you liked this video, please hit this like button. So let us start with the solution. So first of all, I will start with AMGM property and then I will let you know how to do it with the graph technique. Okay, so AMGM, as everyone knows, is nothing but A plus B by 2 is greater than root AB. This is your AMGM property. Okay, so this is an advanced level sum, so I can actually assume that you always know this. A plus 1 upon A is greater than or equal to 2. It means the minimum value of A plus 1 by A will be equal to 2 and the other values will be greater than 2. Okay, so moving ahead, we need to make this into the kind of AMGM property. How to do that? So let me first concentrate on the first bracket itself, then we will concentrate on the second bracket, right? So this is something like A square minus A plus 1 upon A the whole square. Just have a look at what am I doing right away. So A square plus 1 upon A minus A upon A the whole square. If you observe carefully, this is A plus 1 upon A minus 1 the whole square. Now the red boxed trick, check this, A plus 1 upon A. This is very well in the form of AMGM. So one task is done. Now we need to move to the next task. Next task is B square plus B plus 1 upon B plus 1. Okay, so B square, let us check, B square plus B plus 1. Okay, so B square plus B plus 1 upon B plus 1 the whole square is what they have said. Okay, the whole square. Now there are two variables, one is A and one is B. So if there are two variables involved, it will be very difficult for us to minimize or maximize a particular question. So we will reduce one variable. We will say A plus B equal to 2 is given by them, therefore B can be very well treated as 2 minus A. So instead of B, I will substitute 2 minus A, and let us check what happens then. 2 minus A the whole square plus 2 minus A plus 1 upon 2 minus A plus 1. Okay, something like this. It is looking like this. Then if we try to move ahead, it is sort of looking difficult. So what I might do, I will scrap this step. See, doing this was very essential. Now you will say why? Just have a look at what am I going to do next. This will be B square upon B plus 1 plus B plus 1 upon B plus 1. Now see, it turns out that it is turning a very much simpler concept right now. Why? Because B plus 1 upon B plus 1 would be equal to 1 only. So B square upon B plus 1 the whole square is what we have right now. So what I will try to do now is replace that B with 2 minus A. Okay, so let me replace that B with 2 minus A. So 2 minus A the whole square upon 2 minus a plus 1 the whole square is my particular expression. Okay, let us have a look at the denominator. The denominator is 3 minus a plus 1. Now in order to make use of AMGM properties, I should have something like this: 3 minus a plus 1 upon 3 minus a, which is far from looking here. So what do? I make some particular arrangement over here. So what I might do is write this to 3 minus a minus 1 the whole square. Now if you check it out, I have done nothing but written 2 in terms of 3 as 3 minus 1. 3 minus 1 is anyways 2. Now what am I going to do is 3 minus a, I will treat it as one term, and 1 I will treat it as some other term, and then I will apply a minus b the whole square formula. So let us start with this trick. So this will look something like this: 3 minus a the whole square minus 2 times 3 minus a plus 1 upon 3 minus a plus 1 the whole square. So this turns out, after I split it, 3 minus a the whole square upon 3 minus a plus 1 upon 3 minus a minus 2 3 minus a upon 3 minus a plus 1 the whole square. Observe carefully, 3 minus a got cancelled. 3 minus a plus 1 upon 3 minus a. This is how it looks, and then minus 2 plus 1. Now to our greatest surprise, we have 3 minus a plus 1 upon 3 minus a. Minus 2 plus 1 literally got cancelled with minus 1, and we have this particular bracket. So basically the first term got reduced to a plus 1 upon a minus 1 the whole square, which you can see over here, and the second term very conveniently got reduced to, where is it, 3 minus a upon plus 1 upon 3 minus a minus 1 the whole square. So just have a look at the question once again. The question wanted this square plus this square and then minimum value. So I will write down the question once again in order to understand it in detail. So the question got reduced to a plus 1 upon a minus 1 the whole square and 3 minus a plus 1 upon 3 minus a, and then we have minus 1 the whole square. If you observe carefully, now this particular expression is totally dependent on a. It means single variable. That is the first thing. And the second thing, this particular expression is very symmetrical. See, some number minus 1 the whole square, then some other number, because it is not of the same form. In the first term it is a, and in the second term it is 3 minus a. So we could say some number minus 1 the whole square. So basically, if these two numbers are different, then what will happen? Over here there will be some other number because it is subtracted from 1, and over here it will be some other number because it is also subtracted from 1. So when will it be minimum? The logic says that it will be minimum when this term and this term is same. So a has to be equal to 3 minus a. Now let me give you a brief reason for that. You are subtracting 1 from some number and you are subtracting 1 from some other number. So if you have both the numbers same, let us say if you have both the numbers same like this, then you will get the minimum value. But instead of that, if you have both the numbers different, over here you have 3 and over here you have 5 minus 1 the whole square. So this will be 2 square 4 and this will be 16, and then it won't be minimized. It won't be minimized because these numbers were not same, right? So the basic idea behind this is these two numbers should also be the same so as to have this expression to have the minimum value. So 2a is equal to 3 and a will be equal to 3 by 2. Okay, the previous example which I have shown, that was 4 minus 1 the whole square and 4 minus 1 the whole square, but that cannot be related with this because over here this is dependent on 3 minus a, right? So if your a is 4, over here it has to be 1 by 4. Hence some people might have doubt about this. So just forget that example, because in that example I will have to take care that the second term is dependent on the first term. So basically the concept is the first term and this term should be equal for the sum to go minimum. So that is it. So you get A as 3 by 2. So at A equal to 3 by 2, the sum is going to have the minimum value. Okay, so in the expression, if you substitute A as 3 by 2, basically this term and this term, both terms will be same, because this A is nothing but 3 minus A. So I can say 2 times A plus 1 by A minus 1 the whole square is my minimum value. So this would be A 3 by 2 plus 1 by A will be 2 by 3 minus 1 the whole square, and then 2 times this will be 9 plus 4 13 upon 6, 13 minus 6 7, 7 upon 6 the whole square. So this would turn to 2 into 49 by 36. So 2 and 36 got cancelled and you got 49 by 18. So this sum has the answer at minimum value 49 by 18. Let us check out the options. Option number D totally tallies with our answers. But it is not necessary that you always do this kind of big ideas and AMGM concept to solve such questions. There is one of the tricks called as the graph trick. If you apply graph tricks, these sums will become very easy. Suppose A plus B is given as 2 and you have been provided with, what was it? It was A square minus A plus 1 upon A the whole square plus B square plus B plus 1 upon B the whole square. Okay, now you can see the degree is 2 and over here 2 or 3 or 4, whatever the degree goes. So definitely the degree is going 4 because this will be B square upon B. So B square B raised to 4 and this will be B square. So 4 by 2 2, and over here also the same thing is going to happen. So this will have peculiarly the shape of parabola. It will have the shape of parabola. See, if you don't know much about graphs, please go and watch our playlist Play with Graphs. Then you'll understand that how am I saying this will be very close and resembling to the shape of parabola. I am saying resembling to the shape of parabola. Now, when will this particular expression turn to infinity? When A is 0, because the denominator will be 0, and B is what? Over here it was B plus 1, and when B plus 1 equal to 0. Okay, so when the denominators turn to 0, the expression goes infinity. So at A equal to 0, the expression is infinity, and at B equal to minus 1, the expression is infinity. But what is the value of B? That we need to know. So A minus 1 is equal to 2. So basically A equal to 3 and A equal to 0. So at A equal to 0, the turns infinity, and at A equal to 3 it also turns infinity. So basically the graph would be something like this. At A equal to 0 it will be turning to infinity, and at A equal to 3 it will again be turning to infinity. So in between we will have the local minima. The minima will be the value between 0 and 3. So definitely it will be the midpoint of 0 and 3. So the midpoint of 0 and 3 would be 0 plus 3 by 2, and you can very well guess that A comes out to be 3 by 2. So once you substitute the value of A as 3 by 2, you are going to get the minimum value of this question as 49 by 80. So basically the graph trick helps you much, and you can literally orally solve such difficult questions. But I also wanted to tell you the AMGM concept, hence I have explained this using the AMGM concept. There's one more idea, that is the derivatives idea, but it will be a very long and lengthy procedure, hence that should be avoided in such questions. If you liked this video, please hit this like button which is shown over here, and if you haven't subscribed to our channel yet, this is the subscribe button which you have to click. Thank you for watching the video, guys. This is Amol More saying bye bye to you.